Welcome back. We're recording a video of us writing Little Man Computer in C++, and it's been a few days since I've last done one of these episodes. So what I thought I'd do today, just to remind myself of what was going on, is to just tidy a few things up and have a look around the code and see if there's anything we don't like, and see where that takes us. A little bit of refactoring work today. Right, let us start with the tests, preferably in an editor. So we have a bunch of tests. We've got a test result class that handles keeping track of passes and failures. We have a test struct that is essentially a named lambda. We have a test fixture, which is a class with a test result and a bunch of tests and assert and run methods. Loads of tests, many of which with names that are far too long, which we might do something about today. A run method for each subgroup of tests, and an overall run method, and then at the bottom there's just a main. Excellent. We also have a header file with our computer and our little man in, and we have the corresponding source file that goes with that, with the implementation of the two classes and a little modulo helper method function there. That's about it, isn't it? Good. So let's do a little bit of tidying here. One thing I'd like to do, probably due to my C# upbringing, is to wrap all of these things in the appropriate namespaces, because setting everything on the global namespace seems a little bit against my nature. So let's see what happens if we do that. So if we create a namespace, assuming I'm doing this correctly, LMC for example, would seem like a logical namespace. Let's see if I've done that correctly. We're going to have to obviously use that namespace in the various places we've used little man and what have you. Yep. So here, I'm assuming, yes, okay. So here what we want to do is swap computer for LMC computer, and little man for LMC little man. Let's see if that is sufficient to get us a step closer. And yep, and then the tests also want the same adjustment. That should be sufficient there. Don't know if this is too broad a change to do just by search and replace, but we'll see if it works. Lots of compiling going on. That seems to be good to me. Excellent. And then I suspect a namespace for the tests would be a good idea as well. Now the question is what to call the test namespace. I don't know how you do nested namespaces. See, tests. Can we do that? I don't know if that's the right mechanism or not. Let us see if that gets the job done. And of course we have to then name things appropriately. see if this does the job. MC tests. That might be a slight improvement. That looks good, doesn't it? So are we happy with those names? LMC tests and LMC. I think that looks okay, doesn't it? Let's store that. Wrap things in namespaces. That looks good to me. So another thing I'd quite like to do is to shuffle these methods here into the same order that they are numerically in here, just as a convenience, I think. So add sub store load. Then branch 0, branch positive input output. Branch. Yep, that looks good to me. I might just put a little break in there, and just so we can see the difference between the fields and the methods. And let's also reorder these accordingly. So that's input output, they go last, like so, and then add and subtract go first. There. That looks all in the right order. And these are already in the right order for the mechanism for parsing the instruction. That looks okay, doesn't it? So we've reordered that, and I think it's probably worth now having a look at our test naming and potentially shuffling the tests around to match as well. The naming we want, the ordering of the different operations. So, computer test. Program counter is initially set to 0. That sounds a perfectly respectable name, doesn't it? Input puts the value of the inbox into the accumulator. That sounds correct. Inbox handles inbox values greater than 999 using modulo. That sounds sensible. Inbox handles inbox values less than 0 using modulo. Again, sounds sensible. Inbox input resets the negative flag. Output puts the value of the accumulator into the outbox. That sounds respectable. And then we're on store, puts the value of the accumulator into the specified memory address. That sounds correct. Load puts the value of the specified memory address into the accumulator. Load resets the negative flag. And then we're on to some of the more challenging values. Adds the value to the specified memory address, leaving the value in the accumulator. So that's probably a bit lengthy, and it's got some things we don't necessarily really care about. So what do we actually want to say here? So we want to say add adds the value in the specified memory address to the accumulator. leaving the value in the accumulator. And then perhaps a little something like 1 plus 2 equals 3 or something, just as a note to ourselves that that's this particular version of the test. And then I suspect we can have the same name for the next test, except with changing our test values to be 3 plus 4 equals 7. I think that's a slightly better clarification of what's going on. So add adds the value of the specified memory address to the accumulator, leaving the result, I think is a better word there. That looks better, doesn't it? And then add resulting in value greater than 999. Results in modulo 2, so the word result. Add resulting in the value greater than 999. It's not very smooth, is it? Add resulting in value greater than 999 results in modulo 1000. I'll leave that for now. Maybe we'll do that another time. Add resets the negative flag, subtracts the value. I think we'll do something similar here, won't we? 23 minus 17 equals 6. So subtracts the value in the specified memory address from the accumulator, leaving the result in the accumulator. That's good. And then we've got another variant of that here with 37 minus 25 equals 12. That looks okay. Subtract resulting in negative value leaves the accumulator with the modulo 1000 result. That's fine. Subtract resulting in negative value sets the negative flag. That's good. Subtract resulting in positive value does not set the negative flag. I think that's a sensible case as well. Unconditional branching changes the program counter. To the specified address. Branch of 0 branches if the accumulator is 0. Changing the program counter to the specified address. Branch if 0 does not branch if the accumulator is not 0, leaving the program counter unchanged. As that's the test, isn't it? Branch if positive, branches if the negative flag is false. What did we say? Changing the program counter to the specified address. Yep. Changing the program counter to the specified address. Yep. Branch if positive does not branch if the negative flag is true, leaving the program counter unchanged. And that's all of those tests. I will just shuffle them around so the operations are in a sort of matching order. And that will tidy things up a little bit, make it slightly easy to follow. That's that lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 1 So I'll leave the program counter at the beginning, and then we want input and output at the end. And I have a feeling load comes before store as well. I will just double check that. Yeah, no, store does become full before load, so we're in the right order there. Good, let's just check the test will still pass. Excellent. And just store and load the other way around. Yep, let's make sure we've done the same in here. We haven't. Okay, that's good. And then we can just check the test names for the little man. So, little man interpreting output instruction results in accumulator value in outbox. Little man interpreting input instruction results in inbox value in accumulator. Little man interpreting store instruction results in accumulator copied into memory address. 25 into memory address 36. I think that's not too bad. Little man interpreting load instruction results in memory address copied into accumulator. Little man interpreting add instruction results in accumulator being incremented by content of memory. Little man interpreting subtract instruction results in accumulator being decremented by content of memory. Little man interpreting branch instruction results in program counter being changed to address being changed. I'm not going to say to address there because the final program counter is going to vary depending on subsequent instructions there. Yeah, and in fact we've left that name there. Little man interpreting branch instruction, branch of 0 instruction with 0 result results in program counter being changed. Little man interpreting branch of positive instruction with negative flag not set results in program counter being changed. Little man interpreting input then output instruction results in inbox value transferred to outbox. Little man interpreting input then store instruction results in inbox value transferred to memory. Little man interpreting input then add then output results in inbox plus value into outbox. Yeah, the names are getting slightly complicated here, but that's all right. I think it's clear what they're saying. Is it? Maybe. Yeah, I'll leave them for now. Little man interpreting a single halt instruction leaves the program counter at 1. Man interpreting output then halt leaves the program at 2. Three instructions leave the program counter at 3. Do we want to make those names consistent? I think that's okay. Halt after branch terminates correctly, and then program counter wraps when it goes beyond 99. Load program populates computer memory. Fine. I think that's okay. Let's just check. I don't think we've made any changes there, but we'll check everything still passes. Looks good. I think one last thing I'd like to do in here, in the little man, is just comment the little programs that we've done here, just for ease of reading later. So that's an input instruction. That's a halt instruction. No, that's not. Sorry, that's an output instruction, isn't it? That's an input instruction. I have to check this several times, I think. Halt. Our little 3 letters correct. That is a store, which is STA25, followed by a halt instruction. That is also a store 36, ooh, yeah. Followed by a halt instruction. That is a load instruction. Followed by a halt instruction. Followed by a dat instruction. I think that's how it's done, isn't it? Yeah. Anything with yeah, that's the way. And then we have that's add 23. That's a halt. And that's dat2. I think that's right, isn't it? Yep. Nope. That is sub, right and sub right, yeah. Sub 34, halt, and dat 25, and branch unconditionally to 7. Doesn't seem any point putting 07 as the value there. That's branch 0, like so. Something like that, I'm going to guess. Yeah. Branch of positive. Input, then output, then halt, and then input store 62. Almost remembering what these things are now. Halt. Getting more substantial programs now. Let's add 4. That is out. That is halt. And that is dat12. That's just halt. That is output. That is halt. That is input, output, and halt. That is branch to instruction 2. That essentially is dat0 rather than halt. And that's the halt. I'm not sure if that makes much in the way of difference there. That's halt, and that's the input instruction. And I'm not going to worry about that. Or am I? Perhaps we can write something like that. I'm not sure that's quite a legal syntax, but whatever. So everything still passes. Just wanted to check we haven't haven't assigned anything in an untoward manner there. And that looks a little bit tidier now. Not a great deal done there, but got a little bit of a feeling for where everything was now. And we should be able to continue from there. This is the only slightly awkward bit there, which I guess we could, if we really wanted to, extract, but as it's only in the one test for now, I think I will leave it. Excellent. So let's see where that got us. So what did we do? We tidied the order of things and renamed some tests and commented some assembler programs. So we ordered members, improved test names, commented LMC code. There we go. And next time we can get back on with doing something useful.